So again, here are Pythagorean, several of our trigonometric identities. Let's go back and remember that the Pythagorean identities that you should get memorized, because you will use these a lot, is we have sine squared plus cosine squared of theta equals 1. Then you have 1 plus tangent squared of theta equals secant squared of theta. And 1 plus cotangent squared of theta equals cosecant squared of theta. Now just thinking about a lot of these, we actually know a lot of these. The reciprocal identities is just another way to rewrite these. So cosecant of theta, we remember that's 1 over sine of theta. Secant then is 1 over cosine of theta. And cotangent is 1 over tangent of theta. Our tangent and cotangent identities. So tangent of theta, we remember that as sine of x over, sine of theta over cosine of theta. Sine of theta over cosine of theta. And then cotangent is the reciprocal. So that means cosine is on top and sine is at the bottom. Our cofunction identities. So when you have a sine of pi over 2 minus theta, we're just saying that it's shifted over, and it really makes the same curve as the cosine curve. So sine, whenever you see this, it's just shifted over. So it's cosine of theta. The next thing, if this is shifted, this is going to be sine of theta. So it's cofunction identities. And for tangent, you can probably guess what that is. That is cotangent of theta. Then the negative identities at the bottom. Sine is actually odd. So when you have a negative in the inside, this will be negative sine of theta. Cosine is even. So whenever you see a negative in the inside, it's just going to be a positive. It's just kind of like if we have an x squared. That's going to be always positive. So this will be just cosine of theta. Tangent of negative theta, if you think about that, if you have a sine, negative sine over positive cosine, it'll end up being a negative tangent of theta. Okay? So let's go ahead and use our Pythagorean identities to help us solve the other trig functions. We're going to find some trig values. We've done this before, but we're going to do this a little differently. Instead of doing it with just the Pythagorean theorem, we're going to use the Pythagorean identities instead. So we're given that sine of theta is 4/5, and then we know that the quadrant is pi over 2, between pi over 2 and pi. So pi over 2 is here, pi is here. So that means I am in quadrant 2, this quadrant here. So if you think about it, why is this important? This is important because it tells us what values or what signs our x and y values are. So knowing that I'm in this quadrant, my x values are going to be negative, and then my y values, because it's up here, because I'm in this quadrant, is going to be positive. So we're in quadrant 2, and we know that our x values are negative and our y values are positive. So we're given that sine of theta is 4/5. We're going to use this trig identity in order to solve for our other values. So we're going to substitute 4/5 into sine squared of theta. So we have 4 over 5 squared plus cosine squared of theta equals 1. So we're trying to find cosine. So let's subtract negative 4/5 squared from both sides. So we get cosine squared of theta equals 1 minus 4 squared is 16 over 5 squared, 25. Now, in order to subtract it, we have to get a common denominator. So this one I'm going to make as 25 over 25. So now we have cosine squared of theta over 25 minus 16 is 9, and then 25 over 25. Now next, we need to square root both sides in order to solve our cosine. So now we know that our cosine of theta is going to be 3 over 5. So we can fill that in. So first of all, we know that our sine is 4 over 5, and it already tells us that the y value is positive, or this is positive. There's no signs there, so we know that that's positive. Cosine of theta is 3 over 5, but it is our x value. So remember that our x values are actually negative. Then our tangent of theta, you can remember that as sine of theta over cosine of theta, or just it's y over x. Remember that the sine of theta is really y over r, and then the cosine theta is x over r. So we really know all of our pieces here. We know what the radius is, we know what x and y are. Or another way to do it is just to do the sine of theta over cosine theta. So let me just show you that way. And then you can choose whichever method you would like to use. So I'll do sine of theta over cosine of theta. So this is going to be 4 over 5 divided by negative 3/5. Remember, when you're dividing by a fraction, so if you do 4/5 divided by negative 3/5, you multiply by the reciprocal. So 4/5 times negative 5 over 3. Notice that the 5 just cancel, so you're left with negative 4/3. And again, if you just take a look at what is the y value, what is the x value, it's just the y over x. Now, the other identities, and you just have to flip it all over. So 4 over 5, that becomes 5 over 4. Cosine for secant is now negative 5 over 3. And then our cotangent is negative 3 over 4. So I would challenge you to use this method just so you can get to memorize the Pythagorean identities. As a hint, taking a look at these, if you're given sine of theta and cosine of theta, for example, then you're going to use that trig identity. You want to use sine squared of theta plus cosine squared of theta equals 1, right? So you have sine of theta, you're going to plug it in to here. And then if you have cosine, then you're going to do the same thing. Sine squared of theta plus cosine squared of theta equals 1. You know cosine, so therefore you're going to plug it in here and then solve for sine. Now for this other example, we are given cotangent. So we have to go back and think about what Pythagorean identity can we use. We want to use the one that has a cotangent in it. So therefore, we want to use 1 plus cotangent squared of theta equals cosecant squared of theta. So we know what cotangent is, so we're going to plug it in here, and then we're going to figure out what cosecant is by doing the same exact procedure as before. So go ahead and try these all out, and then the next video will have the answers for you.